In this algebra video walkthrough lesson, we're going to take a look at function machines or input and output boxes, and this is standard 5083 part 1. We'll be looking at this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself. You'll find it under our algebra video walkthroughs section, and it's entitled Function Machines or Input and Output Boxes. Here are the directions. Use the rule and the given values to find the missing values. We have 4 function machines with 4 separate rules. Let's take a look at the first. In the first, we have the rule multiply by 5, then subtract 3. So you have to do it in this order in a function machine. We're going to input a certain value. In this case, it's 2, and we're going to apply the rule to it. So let's set up our work below. It's always a good idea to show your work. You can print out the work page that goes along with this worksheet as well. It's just known as page 2. Let's take a look at the rule. We have the rule, which is multiply by 5, then subtract 3. I'm going to set up a little T-chart because we'll have to write the reverse rule when you're given an output value. So that's a look ahead, what we're going to be doing. All right, so let's input this 2. So if we input a 2, all right, so our value is 2, and we're going to multiply it by 5, then subtract 3. And again, you have to do it in this order from left to right in a function machine. So now we've got 2 times 5. You're probably thinking, oh, I know that. That's 10. If you're thinking that, good for you. Then we have to deal with this minus 3. So we're going to subtract 3 from 10. And you're probably thinking, you know what that is. You can probably do a lot of this mentally. And 10 minus 3 would be 7. So that is what would happen. You'd input a 2, multiply it by 5, then subtract 3, and you are left with 7. Let's try the next one. So we're going to we're going to input a 4. Let's go ahead and there we go. This time we're going to input 4. Apply the rule times 5 minus 3. 4 times 5 would be 20. And then we subtract 3. 20 minus 3 would be 17. So there you go. Next up, we have 7. We're going to input into our function machine where the rule is times 5, subtract 3. Or multiply by 5, subtract 3. So now we will change our work here. Get rid of what we had up. Keep moving that line on us today. So I delete this. Here we go. Input 7. And we'll multiply by 5. Subtract 3. That's our rule. So 7 times 5. You're probably thinking 35. Good for you. And then we're going to subtract 3. 35 minus 3. Probably can do that mentally as well. 35 minus 3 would equal 32. So you'd output a 32. Now, we have the opposite going on here. We are given the output value, and we have to go ahead and reverse the rule. So we're going to be heading in the opposite direction here. So we take the 42, and when we're using the opposite rule, we have to do the inverse operation. So we're heading this direction. The first thing we come across is subtract 3, and the inverse for subtract 3 would be to add 3. Addition is the inverse operation to subtraction. And now we're going to handle this 5. Multiply by 5. Well, the inverse, you're probably thinking, inverse of multiplication would be division. There you go. Good. So we'll divide by 5. So we're going to add 3, divide by 5. We'll start off with this 42. So we'll take 42, add 3, then divide by 5. 42 plus 3 will give you 45. And if you know your basic division facts, you can see this coming. 45 divided by 5. Or you can think to yourself, 5 times what equals 45? And of course, that would be 9. So there we go. So if you output the 42, you must have inputted the 9. There we go. Now we're moving right along here. Next up, you can see we have another value up there that we outputted, and that is 52. So we'll take the 52 and we'll apply the reverse of our rule, or the inverse of our rule. We'll add 3, divide by 5. Should be a division symbol here. Let's back that up a little bit, clean that up. 52, add 3, divide. Oops, happening again. There we go. Okay, so now we've got 52 plus 3 would give us 55. 55 divided by 5. That would equal, you're probably thinking, I know that. But in case you don't, you could set it up traditionally, the traditional long division algorithm. 5 goes into 5 one time. 1 times 5 is 5. Subtract, get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtract, get 0 as your remainder, and 11 would be what we'd have here. So, if you outputted a 52, you must have input 11. Now let's take a look at 57. Take some time to clean up our workspace down here. A lot of technical difficulties there. There we go. All right, now we're back in business. We start with 57 in the output side, and we have to apply the reverse or inverse rule. 57, probably getting the hang of this by now, plus 3 divided by 5. All right, 57 plus 3, you're probably thinking, 60. And 60 divided by 5. Not sure what that is. You could divide. 5 goes into 6 once. 1 times 5 is 5. Subtract, get 1, bring down the 0, leaving us with a nice number to work with, 10. So 5 goes into 10 twice. 2 times 5 is 10. Subtract, you're left with 0. So there we go. And that would give us 12. So we must have input 12 into our function machine. Okay, now let's move on. We've got a different rule for the second function machine. You can look on your paper and see that the rule is add 7, divide by 2. We're heading in this direction here, so we have to add first. A little different than order of operations with this input machine. We have to add first, then divide by 2. So now we've got our rule. We'll rewrite down here. Add 7, divide by 2. Okay, if you're heading in that direction, then the inverse rule, as you probably can see, we're going to need down here, so we'll write that as well. So we've got heading in this direction, it would be the inverse of division, would be multiplication. So we'll multiply by 2, then subtract 7. Okay. We can finish off our T-chart up down below and get started. Okay. All right, so we input 3. Let's see what happens. So 3, and we'll apply our rule, plus 7, divide by 2. 3 plus 7 is 10. 10 divided by 2, or 2 times what equals 10? Probably thinking 5. Good for you. So there you go. Once you get the hang of these, and you realize how to work your values with your rules or reverse or inverse rules, you get these flowing pretty quickly. So 7 is our next one. We'll input 7. Okay, and then we're going to add 7, then divide by 2. You might, like again, you might be able to solve these mentally and go ahead. You can finish these up and then check your work if you'd like to at the end. So 7 plus 7 is 14. 14 divided by 2. So 2 times what equals 14? Well, 14 divided by 2 would equal 7. So there you go. So if you input a 7, look what comes out, a 7 as well. Now we'll work with 11. We'll input that into our function machine. All right, we have 11 plus 7 divide by 2. All right, 11 plus 7 is 18. 18 divided by 2, that should be, let me just write over that for you so you can see that this should be divided by 2. 18 divided by 2. And you're probably thinking 2 times 9 would equal 18, and you'd be exactly correct. So we'll put that in our output side. If we input 11, we would come out with 9. Now, if we want to output 11, we have an 11 over here, and we'll apply our inverse rule. 11 times 2 minus 7. 11 times 2 would be 22, and we'll write that down here. 22 minus 7. 22 minus 7 would give you 15. So, if we input 15, we would output 11. Seems like we have kind of a trend going on here. Let's see. Now let's move on to the next one. Okay, so we're outputting 20. So we'll look at our inverse rule. So we'll go with 20 times 2 minus 7. 20 times 2 would be 40. 40 minus 7 would give you 33. Okay. Now we're going to take a look at this last one. We've got 6, and it's in the output side, so we'll run it through over here. So we've got 6 times 2 minus 7. 6 times 2 is 12. 12 minus 7 would equal 5. And there we have our 6 times 2 is 12 minus 7. That'll give you 5. Just double checking my work there. It's always a good idea to double check your work. There you go. And we'll move on to number 3. If you're getting the hang of this, good for you. Feel free to try it by yourself at any point here. If you're not sure, you get stuck, then you can resume the video. Or if you want to just check it out, you can. All right, number 3. We've got a rule of minus 5 times 4. And on the inverse rule side, we have some that we'd have to deal with over here right off the bat, actually. So we'll head in the opposite direction. So the regular rule this way, inverse, opposite. All right, so the inverse of multiply by 4 would be divide by 4, then add 5. And our first value given is on the output side, so we'll take a look at the inverse rule. So 4, we're dealing with 4 divided by 4 plus 5. 4 divided by 4 is 1, and 1 plus 5 would give you 6. We'll move through these a little bit more quickly this time, so let's check it out. All right, so now we're outputting 8, so let's go with 8 divided by 4 plus 5. 8 divided by 4 would be 2, and 2 plus 5 would equal 7. There we go. Now we've got 12 we're dealing with. We'll divide by 4. Then add 5. Addition symbol here. All right, so 12 divided by 4 is 3, and 3 plus 5 equals 8. And now on the left side, we're going to input 9 into our function machine. So we'll go with 9 minus 5 times 4. So 9 minus 5 equals 4, and 4 times 4 would be 16. Then we'll go with 11. So we're moving right along now. 11 minus 5 times 4. 11 minus 5 would be 6, and 6 times 4 would be 24. If you're thinking that, good for you. Now we'll input 12. That's our 12 here. Minus 5. Multiply by 4. So 12 minus 5 would be 7. 7 times 4 would be 28. And there you go. Last but not least, we'll take a look at that last one, number 4 over here. And our rule. We have a different rule for this one. Set it up again. All right. So our rule is divide by 2, multiply by 3. We'll set up our T-chart again. Okay, so we're going this way first, and then the inverse would be the opposite or inverse operation, so it would be divide by 3 and then multiply by 2. All right, so we have some values in the input side here. Go ahead and take this 6, put it into our function machine. 6 divided by 2 times 3. You could probably do these mentally. 6 divided by 2 would be 3, and 3 times 3 would be 9. So if we input 6, we'd output 9 with this rule. Now we've got 8 we're inputting. 8 divided by 2 times 3. 8 divided by 2, or 2 times 4 would be 8. So 8 divided by 2 would be 4, and 4 times 3 is 12. On our output side, and we'll input 12 this time. Divide by 2, multiply by 3. 12 divided by 2 is 6, and 6 times 3 will give you 18. There's our output value, and now we'll work with the inverse, or we'll head the opposite way through this function machine, starting with 30. Go with 30 divided by 3, multiply by 2. 30 divided by 3, you're probably thinking, 30 divided by 3, well, I know 3 times 10 equals 30, so 30 divided by 3 would be 10. And then 10 times 2 would be 20. Starting with 36 on the output side, heading through the opposite direction of our rule, we'd be looking at 36 divided by 3, multiply by 2. 36 divided by 3. Well, 3 times 12, you might be thinking. 3 times 12 equals 36, so 36 divided by 3 equals 12, and 12 times 2, a couple dozen would be 24, if you're thinking that one. Nice job. Now we're looking at outputting 39. 39 divided by 3. Whoop. Got 39 divided by 3. Multiply by 2. So if you don't know how to divide that one, it might be a good idea to show your work on the side here. 39. It's not a basic fact you're probably familiar with. So 39 divided by 3. You can see how it'll probably work out nice and evenly. So 3 goes into 3 at once. 1 times 3 is 3. Subtract. Get 0. Bring down your 9. 3 goes into 9. How many times? Well, you're probably thinking 3. If you were, good for you. So 3 times 3 is 9. Subtract and get 0. And there you go. 13. So we've got 13. Let me just bump this down a little bit. So you've got 39 divided by 3 equals 13. And you're going to multiply that by 2. So we've got 13 times 2. 2 times 3 is 6. 2 times 1 would be 2. So 26 will be your final value. Input 26, output 39. So there you go. There's a look at function machines and as well as input-output boxes. They're one and the same. Thanks for checking out worksheetsandwalkthroughs.com, and we'll see you again next time.